Alright, so in this video we're going to show you how the Prisoner's Dilemma file program works, and also basically by doing part 2 of this assignment and then starting to look at part 3 of developing your own algorithm. So let's start with number 7 and just kind of talk about how we're this of course video assumes that you have a familiarity with the Prisoner's Dilemma tournament. I also want to point out that for this particular course you're going to see an algorithm that's provided by PLTW that's a little bit different than the one that is that I'm using. So I'm actually, in my class, I'm using a slightly altered point structure to make the strategy a little more dynamic. So Canopy is open. So what I'm going to do is I'm going to go to GitHub. And this is the class repository that I've chosen for this. And you see I have a few others as well. Let me use this repository. And I'm going to open it up in Explorer. And I'm going to open by doing right-clicking of the repository in GitHub, of course. And then I'm going to open the file Prisoner's Dilemma, the Canopy document, just by double-clicking it, and then it will open up in GitHub. Now, that's where that is. So I did skip one step, of course, and that's the creating of the master branch. Sorry, a testing branch from the master branch. And I'm going to go ahead and go back and do that. So if just want to point out, why is it that you want to create a testing branch? And it's because if you make changes to the master branch and you later want to revert those changes or undo those changes, you won't be able to do that without pulling again from the master fork, assuming that no pull requests have been approved by the master branch. So to kind of go around that, the best thing you can do is create your own testing branch on your fork. So if I create a branch, and actually I'm going to skip that step myself because I am the master branch, master top branch. So if I wanted to create a branch, I can do that by clicking here and going new branch name, and I can call it testing JC. Okay, so I'm just going to skip that only because I don't want to mess up the master branch. I'm pretty sure it'd be all right, but we'll leave it as it is. But you can do that. You can create that. And then you can switch back and forth between your master branch and your testing branch. And not only that, when you do, Canopy will automatically update with your old branch, whatever branch you currently are on. So if you have a file, your team file, open up in your testing branch, but you want to see what your master branch had or has, and the case may be, you can just switch in the branch on GitHub, and it will automatically update that in Canopy. Excuse me. All right, so I'm going to go ahead and go back to that. Go back to that window. So we open up in Explorer, and here's our Prisoner's Dilemma, which I believe I already did open up in Canopy. Did I close it? I did close it. Open up our editor, and then open up the file in Canopy. Okay. So we're going to walk through what's going on in this. So the instructions for number 8 say to load the Prisoner's Dilemma and then execute the code. So as a reminder, how do we execute code? We just hit the green play button, which is slightly off of my window right now. But once and of course it's also waiting for my kernel to start. And if it doesn't, I'll just restart the kernel, because when in doubt, we always restart the kernel. So it's not going. I'm just going to read the directions for now while my kernel gets going here. And let's switch to that. Okay, so we open the Prisoner's Dilemma.py file. We're going to execute the code, which imports Prisoner's Dilemma player algorithms from other files and defines several functions for running the tournament. The code also simulates the tournament among 4 of the imported strategies called example 0, 1, 2, 3. Data from a round-robin tournament among 4 players each is used. The strategies is printed on the screen and stored in the data file. Scroll up to see examine the 3 sections of the printed output. So there's 3 sections. There's one called lineup, player versus player, and a leaderboard. So we're going to get similar things when we do the play tournament function with our strategies. My kernel still hasn't started, so I'm going to restart that and just kind of get that going. Restart the kernel. When in doubt, restart the kernel. So there we go. Okay, so now I can execute my function. And when I execute my function, it's going to automatically output all this information. Now, I want to, again, I'd rather use the document that you're looking at for the assignment, because that has the non-altered point structure. You'll notice that on mine, I have completely different point totals, and that's because I have changed what amount of points you get for each result. So for always betraying, it's a different point total, and then for colluding and then getting betrayed, there's a different point total involved in those as well. So I'm going to look at this one and kind of walk you through what these all mean. Okay? So when you run the file, you're going to get these 3 sections. So the first one is the example strategies. So the lineup in this case. So and this is sort of like a default. It happens because you store the functions. It also stores other functions in the file, but this particular set here kind of walks through here. So collude, betray, alternate, and then but collude but retaliate. So it's kind of a description of what each one does. And you'll also notice that there are strings in the team files that you can assign. So if we had rostered team files that had been named already, these names would actually show up. And this is the team name for example 0, and this is the description for example 0, and so forth all the way down the list. So example 0 is one person who's always going to collude no matter what. There's a very simple, super basic strategy. Example 1's always going to betray, super basic example strategy. E2 is going to alternate. That means that it's going to collude, then it's going to betray, then it's going to collude, then it's going to betray. Whereas example 3 is going to collude and continue to collude, except if they have been betrayed, they're going to, in the next round, betray. So, and then go back to colluding. So that's the example strategies in a nutshell. And you can examine those example strategies, again, if you go back to the repository, your fork, clone repository, and open up any of these files. So if I open up example 3, for example, no pun intended, and go to Canopy and look at that, you can see this is the function that describes how it's going to move. So you'll see if the len of my history is equal to 0, it's the first round, what do we do? But if my history less than 1 is equal to C and their history is a B, so if I colluded last time and they betrayed last time, I'm going to betray, otherwise I'm going to collude. That's the strategy. And again, notice, here's the team name, and here's the strategy name. And if we go back to the log, there they are, right there, collude but retaliate. Collude first round, collude accepted in round after getting a severe punishment. So that's the doc string to kind of go with that description. Okay, so back to the document. There we go. So that's the first section, who's in the examples. Section 1 is a player versus player account of how much points they got versus that player. So here's player 0, the example collude strategy, right? Obviously, they don't play themselves. But if they play against player 1, they got negative 500 points for playing them. If they play against player 2, they get negative 250 points. And they play against player 3, they have a net 0. And then here's the matchups with player 1. If player 1 plays player 0, they get 100 points. And this is just sort of the, you know, what this is basically is actually an average score per round. Okay, so you'll notice that in the collude and betray situation, the betrayer is always going to get 100 points, and the colluder is always going to lose points. Okay, and so per round, on average, player 1 is gaining 100 points every round they play against player 0. Okay, and then at the end, these results are averaged by how many rounds they played. So player 1 is the winner in this tournament because their average score was negative 13 points. Whereas player 2 is second place, the points with the alternate collude and betray strategy, and then the collude but retaliate was third and the collude was fourth. So basically, this is a sample tournament. Here's the individual matches, and here's the net result. So it's the net result that you are trying in this project. You want to be on the top of the leaderboard in this project. That's pretty much it. All right, so there is a variable that's called reports that is also generated in this thing. So if we go to Python and we go to the next line and we type in, as I say, reports 3 and 0 and press enter, we get sort of that output. And I'll explain what that is in just a second. Okay, so what I've done is I've executed that code, and you can see I have a report. Now, what does this report mean? It's actually, this is kind of not as nice, neat, and sorted as this particular section, but this is a third section that is not printed automatically. But if I print it and show what's stored in there, this is the game data for team 0, E0, example 0, the collude strategy, right? So here's how we read this. Against P1, this is what they had right here, C, 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 and this is what they were up against, B, 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 right? And then so forth and so on, all the way down the list, and then the new line. So the way it prints out, unfortunately, is not the best in the world. It is what it is. So collude, betray, and then also what they did against example 2, what they did against example 3. You may get better format than I did, but you can see they printed escape characters, line breaks, just automatically put out there. Not very helpful in that regard. I kind of have to sort through this and read it. But all this really is just what happened in the matches. What happened from here, what happened from the start to the end. Okay, so let's continue on. So we've done the reports, and then we're going to now store all this information into a few more ideas. So we're going to take the following information, execute following commands, and examine the output. Scores, moves, reports equals main play, and actually all I have to do is just copy and paste this, right? Just copy and go to Python, and we'll just paste it into input 3, paste it in there, and examine the output. So what happens? Okay. In this case, we have example 1, example 2, and team 0. Okay. Now, oddly enough, team 0, that's the team that I myself as the teacher have actually assigned. Okay. So this rules is the name of the team that I've assigned, and then I haven't named a strategy or programmed a strategy yet, so there's really not much to report about that. But just to show you, here's the main play. We're pitting up against example 1, example 2, and team, and we're getting scores, moves, reports, and it's printing out all this information as due to the main functions, right? So again, what happens? We got individual reports, how did player 1 do against player 0, how did player 1 do against player 2, how did player, and so forth, right? All the way down there, and then we can see that negative 33 points with this, there, and then this. Because I haven't programmed an algorithm yet, I, of course, am at the bottom of the leaderboard, and that's okay. So when we examine that output, we're just basically getting a report when we do that. Now, check this out. What if I type this in? What if I do example 1 times 3 and example 2 times 2 plus example 3 times 2? Let's see what happens if I paste this in. See what this print gets out. Okay? We run that, and we see that we actually now have included example 1 3 times and example 2 twice. So we do scores, moves, reports, main play, example 1 time. So basically, we are actually including copies. So we could actually see what the strategies do against each other, right, in that regard. So we do that, and then we can see that that's our output. So it's very similar to the report that we see. Now, the function main play is a single argument, and it's supposed to give it a list. The purpose of that list, based on your examination of the program output, note that multiplying a list and then to produce a list with repeated elements. So this particular one is an example of this. So we're actually getting and providing normal lists information about what strategies we're trying to implement. So if we want to import team 1, we can replace this with team 1, right? So that's basically the function that allows us to compare two teams, right? So for example, I can do nice and easy main play and not store any of the results. If I just type in main play, open parentheses, and let's say I do example 3, which we haven't looked at yet, right? No, we did example 4 and example 5. Let's see if there's any strategies in those, right? So if I do that, I get, okay, so I don't get as clean of a report if I do that, and it's just going to give me random output. But instead, if I assign it to values, that's a lot easier. So if I just take that same input, I'm going to do the same thing. We're going to go as what was it? Scores. What was it? I lost it. No, not that one. Scores, moves, reports. So you kind of want to do that. That way it prints a lot nicer. So there's the two strategies up against each other. And you can pit as many strategies against each other as you want, or as few as you want. And you can even pit yourself against yourself if you want, your own strategy against your own strategy. So you can see that in this case, the collude first 100 rounds unless betrayed is used right here. So that's the way that strategy goes. Okay, now what else do we got to know about this? If we examine past moves, the simulation program represents a decision by one of two characters, C or B. We've kind of talked about that already in this video. Before making a decision each round, each player or algorithm can consider what has happened in the previous rounds. The algorithms have the previous round's information in the form of a string. For example, CCB indicates the player colluded the first 2 rounds and betrayed in the most recent round. Each player can consider 2 strings, one for their own history and one for their crime partner's history. Consider the following 2 histories. If we have CCCCCC and your crime partner's history is CCCCCB, you can tell that 5 rounds have been played already. What should each player's score be based on? Actually, in this case, it looks like 6 rounds to me. What should each player's score be based on their move? Now, of course, your answer will depend on the structure that you're using. If your teacher alters the structure, your answer is going to be different than what it is if it's in the default. But notice that they collude all 5 rounds, the first 5 rounds. There's no change in score. However, the crime partner will get 100 points for this betrayal because their partner colluded, and the colluder would lose either, in the default case, it would lose 500 points in this case. Okay, so now we're going to take a look in this case. The 4 players in the zone use 4 different algorithms. Path and code method strategies is shown below. Only the algorithm in example 3 considers what has occurred in the previous rounds. It uses the my history and their history thing. So this is basically a copy of what's in the example files, and you can see these for yourself if you open them up in your repository. Example 0, there's no usage whatsoever of the arguments. Return C. Same deal with 1, you can return C. Actually, it should be return B. It should be always betray, right? It should be return B here, right? Collude, then alternate. There should be a B here. So there's a couple of errors in here. There you go. That's my gift to you. There's a couple of errors in this document. This should be return B. This should be return B here. And then this one's correct. This one's correct. So it's only going to betray if the previous person, if they colluded in the previous round and they got betrayed, they'll return a betray. So a 10-round match between player 0 and player 1 results in the following. Score for negative 5,000, score of positive 1,000. All right. So we can run a tournament with example 2 and 3 among the strategies, and then we also would get an output tournament.txt. The simulation program will have stored that file in the same directory as the simulation program itself. So if I open the file, simulation, when the simulation runs 100 to 200 rounds of the limit between each pair of strategies. Scroll down until you find the data stored for example 2, example 3. Is it different than your prediction? If so, how? It's dependent upon the strategies it is collaborating with and competing against. Discuss this one and more. So in other words, think of it as your strategy obviously is going to be different depending on the strategy that is programmed. Okay? So developing your own algorithm is going to be basically you taking and analyzing scores and history, because you can make different actions depending on scores and history. You can even introduce a random element and even introduce weighted random elements into your own study. So now I just also want to point out one other thing. So I'm going to open up the Team 0 file, which is the file that I have assigned myself in this class. So here's my Team 0 example. Now obviously right now there's nothing in the strategy other than return C, just to make sure it works in case we accidentally call it, right? Well, what if I want to say, let's make the strategy a little more involved, okay? So let's say if len of my history double equals 0, right? And we're going to return, let's say I want to betray the first round, okay? So what this means is return my history 0, so I'm going to betray in the first round. What if, and I'm going to use a series of elifs here, and I'm going to do my history double equals 1. What do I want to do here? Let's throw them off and say I'm going to return collude this time, right? Elif, len, I'm just kind of doing this, right? Double equals 2, and I'm going to return, I'll betray this round. So it's almost like an alternating strategy, right? But then, once we get past that, okay, I'm going to say their history, right? All right, so let's say their history. Let's say the, let's see the, look at this. All right, let's say the last time that they, let's say if they colluded last time, I'm going to anticipate that they're going to collude again, so I'm going to return B, right? And let's say, oops, I forgot a colon there. And let's say that maybe the last time, let's say that if they did, let's see, just last time. I'm not gonna get too complex, but I'm just kind of giving you an idea, right? Let's say they betrayed last time. Well, I'm gonna betray, collude this next time. And then for here, I'm gonna give this as an else. All else fails. If none of that's true, which it will be, I'm going to return C's, just to make sure. So that's my basic algorithm. And I know you're looking at this and going, well, it's 14 lines of code. That's not basic. Well, it depends entirely on what you want to do. And you have a lot of options in your code and your algorithms, and you'll be planning these on paper. And I just kind of made this up on the fly just to kind of give you an idea of what we would have from here. All right, so I'm going to store this file. I'm going to save it, actually, right? So now when I execute prisonerdilemma.py, Team 0 is now stored. So I'm going to run a tournament. Scores, moves, reports. Remember, that's kind of how we're going to do here. Play, what was it? Mainplay. Mainplay was the name of the function. And I'm going to throw in Team 0 against, let's say, example 0. Right, example 2. Like do example 2. Okay? So let's see how my strategy matches up against example 2. And I forgot I got to put this as a list. So what you got to do is you just got to basically make a list of your participants. Okay? Team 0, example 2. So I do that. And I can see that here's player 1, player 0 is my strategy, which I still haven't named. And then player 2 is the clue, then alternate, right? So my strategy is P0. Against them, I had negative 247 points. And it looks like I beat them by a very thin margin. 1 point to be exact, okay? So that's an example of how you can test your strategies against the example strategies. And you can certainly include more, right? You could include, let's throw in example 1 in here. Oops. Let's throw in example 2. Let's throw in, whoops, I lost it. Let's throw in example 3 in here, right? And we can kind of see how we match up against all of those, right? And then you can see here I'm actually second. The betray strategy is still winning in this case. So, you know, it is what it is. So that's something for you to try to play around with. And the whole point of you in this tournament is coming up with an algorithm that will win out against all of your other classes of algorithms. In the sample class I'm showing you in this video, there's actually 14 teams. 14 teams involved in strategies. And then if I write a strategy, that's a 15th team. So we'll have a lot of fun with that. All right, guys, I hope this video helped you. If it did, please smash that like button and subscribe to eSystems Engineering. Have a wonderful rest of your day.